Hello students, we're taking a look at section 4.2. This is the lesson on the second derivative. Second derivative gives information about concave up, concave down, and inflection points. So you can get this worksheet on Blackboard. And what we find out when we read this is that the second derivative, now first of all, concave up just means, I always write it this way, concave up is like a smiley face and concave down is a frowny face. And if there's a change of concavity from up to down, that is called an inflection point. So on this graph, you'll see that you have a concave up here. And then it's still concave up to here, and then concave down to about here, and then concave up and concave down. And a change of concavity is right here. So this point right here, you see that it goes from concave down to concave up, okay? And then at this point here, it goes from concave up to concave down. So these are two inflection points on this graph. There's another one here, concave up to concave down. All right, you get the idea of what an inflection point looks like. So I'm going to come down here and start working these problems. Okay. And the problems say, hold on, let's look at the directions. Find the intervals over which f of x is concave up or concave down. Find all inflection points. Right. So this is all about the second derivative. And the second derivative, as I've written up here, the second derivative gives information about concave up, concave down, and inflection points. And remember, an inflection point is something like it goes from concave up to concave down. That is a kind of like a S hook. It's concave up, concave down, or just the letter S. All right, so I've given you the answers to 1 through 4, and you can check that out. What I want to really get down to is the first problem, and we've already taken the derivative of this x to the third minus 6x squared plus 9x plus 1. It's 3x squared minus 12x plus 9. So I have that written down here, 3x squared minus 12x plus 9. Now I need the second derivative, which is 6x minus 12. And this time we're going to set the second derivative equal to 0. So I set it equal to 0. I got 6x equal 12, divide by 6 and get x is equal to 2. Now Math Excel is calling this a partition point. Okay. You can call it the 0 of the second derivative. I think technically critical number is for the first derivative, but it is a critical number. And let's put that on a number line. So in my number line now is the second derivative number line. That's why I keep emphasizing to label your number line. And I put the 2 here. That was the partition number, as they call it. We're going to try a value to the left of the 2 and one to the right of the 2 into the second derivative. So I tried 0 and I got negative. I tried 3 and I got positive. So up on my number line, I'm going to write that that's negative and that's positive. Now what this means is this is concave down, so second derivative, and this means concave up. And a change of concavity is an inflection point. Right? And there's my conclusion. F is concave down on negative infinity to 2. F is concave up on 2 to infinity. F has a point of inflection at 2f of 2. So I have to take that 2 and put it right back into the original function, which I never wrote down here. So I have to go 2 to the third minus 6 times 2 squared plus 9 times 2 plus 1. And that gives me a value of 3. You can check that on your calculator. All right, so there's the first problem. I'll be back to do the second one.